All right, let's look at the homework 5.6, problem number 4. All right, so the question is actually asking us to use the program in Appendix X. Instead, I'm going to use Geogebra since it's available to everyone. All right, so we want to use the midpoint rule to approximate this definite integral correct to within 0.01. Right, then we want to find the midpoint rule value down here. All right, so let's do that. So first, I'm going to open up a GeoGebra. So you can simply Google GeoGebra, right? And GeoGebra Classic would be the one I'm using. All right, so click on GeoGebra Classic. Then opens right up. There are versions that you can do it directly on the browser, and there's another one you can actually download it so that you can use it without internet connection. Since I have an internet connection, so I'm gonna just use the one on the browser. All right. So first thing is I'm going to define the function. So I'm gonna call f of x is equal to square root of x plus 6. So that will be the integrand here. So integrand is square root of x plus 6. All right, and then I'm going to define n, but I'm going to be able to change the n value. So I'm going to something called a slider. So I'm going to use this slider tool and click here. And the name is going to be n. And it's going to be an integer, and 1 through 30 increment is 1, so that's probably plenty. So we have that. All right, then I'm going to define the delta x value, which is just a b minus a over n. So I'm going to just do that, and I'm going to have to find the Greek letter uppercase. So delta x is going to be 7 is the upper limit, then lower limit is 3, and divide by n. All right, then hit enter. All right, so this way I can actually change the this n value. So as I change n value, delta x value changes as well. All right, so we have that. All right, so we want to use midpoint rule, and unfortunately, GeoGebra doesn't have a midpoint rule. But this one has a left sum, so I'm going to actually tweak a little bit, right? So I'm going to use left sum, right, which is here, right? Then what we're going to do is I'm going to shift the function to the left by half of delta x so that the left sum actually computes the midpoint rule. So we're going to take f, and then we're going to have to shift it to the left. So I'm going to add 1/2 of delta x. So delta x over 2, right? So this is a shifted version of the original function to the left by 1/2 of delta x. And the starting number is 3, ending number is 7, and the number of a rectangle will be n, right? And hit enter. All right, so this is going to be the midpoint rule. You can actually see the picture as well. Let's see. I'm gonna have so here's a picture. Maybe I should move it a little bit here. All right, so I'm going to move this. All right, then you can see as you change the number of rectangles. Here's a 2 rectangle, 3, 4, 5, 6, 7, and so on. All right, so you can do that. Maybe I'm going to stretch this out a little bit so that we can see this guy a little bit better here. All right, so I'm going to just stretch it out. All right, and maybe stretch it even out here, and all right, so like that. All right, and then what we want to do is actually I'm going to rename this guy. So this is a midpoint, so m sub n would be a good one. All right, then I'm going to go ahead and compute the actual integral value. So I'm going to call that value I is equal to integral. Integral, and the function is f. and the starting number is 3 and ending number is 7. Right, hit enter. Right, so this is the actual function value. Right, actually I'm going to change the precision here, so I want to see a little bit more digits, so I'm going to setting. Right, then I'm going to put, let's say, 4 decimal places, like just actually let's go 5. All right, so we have that. All right, so we have that. So this is the midpoint rule with a 1, and then here's the integral here. All right, then here, if I change this value to 2, so you have 2 rectangles, and you can see that it's applying the midpoint rule instead of the left sum here. So you have to do a little bit of shifting to get it to do that. All right, then we want to find the error. Error is going to be absolute value between integral value and the midpoint rule value, right? So right now, when n equals 1, so using a 1 rectangle, the error is 0.0183, so it's bigger than 0.01. So I'm going to change this value to 2. Right? So you can see that already, once you have 2 rectangles, the error is going to be actually less than 0.01 already. So actually 2 rectangles, approximating rectangles, are sufficient. So I'm going to go here, and then answer is going to be 2. Let's check the answer. Right? Submit for testing. All right, I came back, and looks like we got the n value correctly. And we just want the midpoint rule value and round the answer to 2 decimal places. So I'm going to just open up a Geogebra back again. All right, 2 decimal places. So this is the midpoint rule value. So you can see that it's a 13.26. We can actually change the setting back to 2 decimal places here, and 2 decimal places. All right, so you can see that it's actually 13.25. So I'm going to type that in. All right, so we got the 13.25 would be the answer. All right, let's check the answer. All right, I came back, and looks like we got this one correctly. All right, that's it. I hope that this was clear.